We've learned all the ways in which we can solve the quadratic equation by hand. We found that we can factor them, take square roots, and even learn to complete the square. However, there's a tool that we've yet to look at, something even more powerful than completing the square. We've all heard of the quadratic formula. Most of us have been introduced to it at some point in our high school years. But unfortunately, many are only introduced to it and are never explained why it is or how it came to be. We're going to start with that. Let's start by looking back at the standard form of the quadratic equation. ax squared plus bx plus c equals 0. We see that there are three number placeholders, a, b, and c. These placeholders can be any real number, with the only restriction that a does not equal 0. So if these placeholders can be any number, for the time being, let's treat them as if they are truly numbers. All this time, we've been solving the quadratic equation for x. Let's see what happens when we solve ax squared plus bx plus c equals 0. We'll start by isolating the constant term. Ax squared plus bx equals negative c. Remember that we like the x squared term to not have any multipliers on it. So let's divide the entire equation by the reciprocal. X squared plus bx divided by a equals negative c divided by a. Just like with the last lesson, we're now going to complete the square. Remember how it's done. We take half of the b term, square it, and add it to both sides. X squared plus bx over a plus b over 2a squared equals b over 2a squared minus c over a. Make sure you don't forget that multiplier of 1 over a in the b term. We've now made the left side a perfect square trinomial, so we can factor it now into a squared binomial and simplify the powers on the right side. X plus b over 2a squared equals b squared over 4a squared minus c over a. We need to simplify the right side some more. Let's multiply the ca term by a common denominator. X plus b divided by 2a squared equals b squared divided by 4a squared minus c over a times 4a over 4a. Now we can simplify the right side into a single term. X plus b divided by 2a squared equals b squared minus 4ac divided by 4a squared. Look at this. The numerator on the right-hand side is starting to look more like the quadratic formula. Remember what we are doing here. We ultimately need to isolate the x. Let's take the square root of both sides. X plus b over 2a equals plus or minus the square root of b squared minus 4ac divided by 4a squared. Let's look at the denominator on the right-hand side, the square root of 4a squared. Because the a is squared, we know that a is greater than 0. Therefore, the square root of 4a squared equals 2a. Rewriting our equation, we have x plus b divided by 2a equals plus or minus the square root of b squared minus 4ac divided by 2a. Now let's isolate the x. X equals negative b divided by 2a plus or minus the square root of b squared minus 4ac divided by 2a. Finally, since the denominators are common, we can simplify this equation into a single term. x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And there you have it. Many people never get to see how the actual quadratic formula is obtained. We simply completed the square on the standard form and isolated x. Let's practice using it with a few examples. Number 1. X squared minus 2x equals 15. Our first step is to always put the equation into standard form. X squared minus 2x minus 15 equals 0. This is because now we can finally identify the a, b, and c terms. We have a equals 1, b equals negative 2, and c equals negative 15. All we are going to do now is just copy and paste the correct terms into the quadratic formula. X equals the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 15, all divided by 2 times 1. Now we can just simplify some arithmetic. X equals 2 plus or minus the square root 4 plus 60 divided by 2, which becomes 2 plus or minus the square root of 64 over 2. Now we get x equals 2 plus or minus 8 divided by 2, or simplified, x equals 1 plus or minus 4. We can see now that we will get two solutions in x. X equals 5 and x equals negative 3. Number 2. 2x squared plus 4x equals 1. First, let's put this into standard form. 2x squared plus 4x minus 1 equals 0. Usually, when we have a quadratic with a greater than 1, we would just divide the whole equation by the reciprocal of a so we can work with it. But now, we can just plug whatever number we have for a into our quadratic formula. With a equals 2, b equals 4, and c equals negative 1, we have x equals minus 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 1 divided by 2 times 2. This becomes negative 4 plus or minus the square root of 16 plus 8 divided by 4, which simplifies to negative 1 plus or minus the square root of 24 divided by 4, which simplifies further as negative 1 plus or minus the square root of 6 divided by 2. This is usually considered simplified enough, however some instructors prefer to have a single term solutions. If that's the case, we can find the common denominator. X equals negative 2 plus or minus square root of 6 divided by 2. We can then supply our solutions for x. X equals the square root of 6 minus 2 divided by 2, and negative 2 plus square root of 6 divided by 2. Number 3. 1/2 x squared plus 3 over 4x minus 1 equals 0. Our quadratic equation here has several rational numbers as coefficients. We can do one of two things. We can use the numbers as they are, or we can multiply the equation by a factor to eliminate the fractions to make our equation easier to read. Let's multiply this equation by 4. 2x squared plus 3x minus 4 equals 0. Now let's use the quadratic formula. X equals negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 4 divided by 2 times 2, which equals negative 3 plus or minus the square root of 9 plus 32 divided by 4. This equals negative 3 plus or minus the square root of 41 divided by 4. Therefore, our solutions are x equals the square root of 41 minus 3 divided by 4, and x equals negative 3 plus the square root of 41 divided by 4. With the ability to use the quadratic formula, we have easy access to getting the solutions to our quadratic equations. Quadratic equations will show up countless times in our journey through mathematics, so it's wise to become acquainted with them now. This was our final lesson in the chapter for quadratic equations. But there are many types of equations we've yet to look at. In the next 2 chapters, we are going to look at some other types of equations and then inequalities.